In the last video we introduced the periodic table. This time we're going to use it to draw atoms and ions. So if you've been given a periodic table, we added the cations and anions at the top, or the valency. So up here we put in the 1 pluses through to the 1 minuses and 0. This will help us to decide with the ions how many electrons are in the outer shell, but we'll get to that in a moment. The important thing is that each of these atoms is made up of 3 subatomic particles. Remember that atoms are very small. A piece of paper is something like 3 million atoms thick. So the parts that make it up are neutrons, protons, and electrons, and each of those carry a particular sort of charge. Neutrons are neutral. They don't carry any charge at all. But protons are positively charged and electrons are negatively charged. It's important because in an atom, the protons and electrons will be equal in number. In other words, they'll balance each other out. But in the case of an ion, you'll either have more protons than electrons, giving it a positive charge, or you'll have fewer protons than electrons, giving it an overall negative charge. Positively charged ions are called cations, and negatively charged ions are called anions. We'll begin with atoms so that we can learn how to draw them, and we usually draw them using something called the Bohr model, and that's what's in the blue just here. And so we'll get some hints as to how to draw it. We'll start with lithium because in the first video we used that from the key to have a look at the information about each of the elements. Before we even start, the first thing that I like to do is go and find lithium in the periodic table, and here it is sitting here. There's a couple of things here of interest to me. The first thing is that it's in the second period. That means that it will have 2 electron shells. Now, atoms are arranged with their protons and neutrons in the center, which we call the nucleus. And in reality, we think that the electrons are traveling around that in an orbit, in a cloud. But when we draw them, to keep it nice and simple, the way that we draw them, if you have a look at the blue over on the right, is that we keep the center, the protons and the neutrons sit in the nucleus, okay? And we just write the number of each. And then we've got these rings around it, and these represent the electron shells. So I can see that this atom is going to have 2 electron shells, and the reason that I know that is because it's in period number 2. Now the other thing about this that's important is, as you look across the rows, period number 1 only has 2 elements in it. And also it will have a maximum of 2 electrons in its outer shell. So when you go to put these in, as soon as this hits 2 electrons, that electron shell will be maxed out. Period 2, or group number 2, so electron shell or outer electron shells for anything in period 2, they'll max out at 8. So as soon as you hit 8 electrons, you need to add an extra shell. And it will be 8 from there on for anything that you need to draw, because really we only need to focus on the first 20 elements. I've highlighted the first 20 elements for you in the periodic table there, and when you guys are in a test doing this, that's the area of the table to have a look in. Don't go scanning through the whole table trying to find lithium, for example. It will be up in that top 20, and that's what you'll be expected to be able to draw. Right, so let's get back to it. We've got lithium. You see that it's in the second period, so that means it's going to have 2 outer electron shells, and I can see that I've got 1, 2 outer electron shells, so that's going to work out nicely. The other thing that I'm noticing is that it's in group number 1, so that tells me that when I draw this, the outermost electron shell will have 1, and I'm getting that from this one here, it will have 1 electron in its outer shell. Okay, so if we start to draw this, let's have a look at the information that we've got, and we'll go back and double check we've got it all right at the end. When I have a look at each element, there's a little bit of skeletal information in here for me. The atomic number tells me how many protons I've got. So that's 3. And then the relative atomic mass is the total number of neutrons plus protons. So if I just take 7, which is the total number of protons and neutrons, and I take away 3, that would be like the protons and neutrons taking away the protons. All I'll be left with is the number of neutrons, which in this case is 4. And we just pop it in here. Now, if I'm drawing an atom, which we're doing at the moment, the number of protons and the number of electrons will be the same. So I don't need to do anything special beyond this except match them. Remember, in the first electron shell I can have 1, 2 electrons, and then it's maxed out. So then I need to go to the second shell and put my third electron in. And this one is now drawn. Just double check that everything's right. Looking back at the periodic table, it is in period number 2, so it's got 2 electron shells, that's right. And it's in group number 1, which means that it's got 1 electron in its outer shell. So that's right as well. Let's move to magnesium. Our first job would be to find it in the periodic table. I'll use pink this time. Magnesium is going to fall here, so this one's going to look quite a bit different. The first thing that I notice is that this one is in the third shell, or the third period, sorry, which means that it's going to need a third electron shell. And looking at my diagram there, I've only got 2, so I'm going to need to add another shell. And now I'm going to proceed in the same way. I can see that it is in group number 2. That also means that it's going to have 2 electrons in its outer shell. Let's start filling in the details that we can. I can see that if I zoom in, I can see that the atomic number is 12. That means that it will have 12 protons. I can see that the number of neutrons will be the atomic mass minus the atomic number, which is 12. So it will also have 12 neutrons. And because this is an atom, not an ion, it will have the same number of electrons as protons. So if it's got 12 protons, it will have 12 electrons. 1, 2, and the first shell is full. The second shell, I've got 1, 2, 3, 4. So I'm up to 6 in total now. 7, 8, 9, 10, and the last 2 in the outer shell. You might notice that when I move to the second shell there, I put my electrons in pairs. You don't need to do that, but I find that it helps me just to quickly reference them, particularly if I need to try and work backwards and identify an atom or a ion from a drawing. Alright, so double checking that we've got this right. I've got 2 electrons in my outer shell. That looks good because look at this, it's in the second group. I've got 3 electron shells, that looks good because that's in the third period. So that one's been drawn nicely as well. Let's move on and have a look at ions. Drawing ions is really similar to drawing atoms, except the major difference is that they won't have the same number of protons and electrons. So the process is very similar. When you are trying to do it, if I just draw a lithium ion instead of a lithium atom, I still go back to the same core information. Have a look here, and we've got an atomic number of 3. That means the protons, there's 3 of them. And when you go to work out the neutrons, same deal. Atomic mass minus atomic number leaves me 4 neutrons. But when I go to do the electrons, what I need to do is leave the outside shell full. Now that means that if you go back and have a look at the table, if it's a cation, it's going to lose electrons, and if it's an anion, it's going to gain them. And in English that means if it's an element on the left-hand side of the table, it's going to lose electrons, and if it's on the far right, it's going to gain them. Because it's easier to just pick up 1 or 2 atoms or pick up 1 or 2 electrons or lose 1 or 2 electrons than to try and pick up huge numbers of them or lose huge numbers of them. Hopefully this makes sense in a second. So if you have a look at this atom on the left, okay, so now I'm talking about the atom here. I'll swap back to green so I keep my color coding right. But if you have a look at this atom here, it's much easier for this one to just give up an electron than to try and gain another 7 in order to have a full electron outer shell. And remember, what it's trying to do is it's trying to jump down a level and become like helium. Okay, it wants a full outer shell. So that means that it will have 2 electrons here, but that electron there in the outer shell, that will be given away. And so now what we're left with is we're left with a lithium ion, okay, and that means that you're going to have a positively charged ion. And it's positively charged because if you have a look at it, what we've got here is we've got 3 protons, okay, but only 2 electrons. So overall, it will have a positive charge because there is 1 extra proton, okay. We'll try that again. So when we go down and have a look at magnesium, same deal, okay. It is also a cation, so it's over on the left-hand side. It's going to want to give up those 2 electrons here in the outside shell, so we're pink this time. So here in this outer shell, it is easier to give away 2 than to try and pick up 6 to have a full shell. So what that will do is give up those 2 electrons. So again, if we do this one, have a look again, you've got your atomic number of 12, which means your protons are 12. You've got an atomic mass of 24, so 24 minus 12 leaves you 12 neutrons as well. And then as you fill this out, instead of having 12 electrons, it will have a full inner shell of electrons. The second shell will also be full with an additional 8. But it will give the 2 away in its outer shell. And so again, what we'll end up with is we'll end up with an ion, but this time your magnesium ion will have a positive charge of 2 because it now has 12 protons but only 10 electrons. So we'll have 2 extra positive charges. And again, if you go back to your table, have a look at magnesium. It's sitting over here, but by giving 2 away, it is now more like the noble gas neon with a full outer electron shell of 8. But because it's got a positive charge, it is an ion, not an atom. Now, when you go to do any of the anions, I'll keep this video short, you'll just be adding electrons to the outer shell. So something like chlorine, for example, would be gaining 1 electron to try and become like argon. Hope that helps.